welcome back. So what we're looking at today is lesson 8, analyzing bivariate data. So let's go ahead and jump right in. So we're looking at animal brains. Is there any association between the weight of an animal's body and the weight of an animal's brain? Use the data in the table to make a scatter plot. Are there any outliers? So here we have all of our values. So we've got the cow, the gray wolf, the goat, the donkey, horse, porter monkey, the cat, giraffe, gorilla, humans on there, the rhesus monkey, kangaroo, sheep, jaguar, chimpanzee, and pig. So here is our table. I'm going to go ahead and fill in those points. So we have 465 for our cow and 420. Let's see, that's 500, so like 423. It's right about there. The gray wolf is 36 and 120. It's right around there. The goat is 28 and 115. It's right about there. The donkey is 187 and 419. Let's see. The horse is 521 and 655. The porter monkey is 10 and 115. The cat is 3 and 26. The giraffe is 529 and 680. The gorilla is 207 and 406. The human is 62 and 1,320. The rhesus monkey is 7 and 179. The kangaroo is 35 and 56. The sheep is 56 and 175. Around there. Jaguar is 100 and 157. The chimpanzee is 52 and 440. And the pig is 192 and 108. So this is approximately what our data looks like. Obviously, it's hard to get exact locations because of the fact that it is a really big scale, especially all these little dots down in here. It's very difficult to get an exact amount. So after removing the outliers, does there appear to be an association between body weight and brain weight? Describe an association in a sentence. So we do have some outliers. So this would be an outlier up here. Change the color. So this would be an outlier. This would be an outlier. Those are some outliers. There does appear to be a positive association going right through there. So seems to be a positive association. Obviously, we're not going to use a piece of pasta on a straight edge, but we did fit a line. For our scatter plot, we want to estimate its slope. What does the slope mean in the context of brain and body weight? So if we look, we have an exact point here at 50 and another one, well, I don't really have another exact one, but we've got one here at 150 and 300. And then we've got, let's see, we've got 300 and 500. So if we calculate the slope between that, so 500 minus 300 over, let's see, those are y's, x's. We said 300 minus 150. 500 minus 300 is 200. 300 minus 150 is 150. And 200 divided by 150 is 1 1/3. So around 1 would be our slope. Obviously, our line is not exact, so about 1. So as body weight increases by 1 kilogram, brain weight also increases by 1 kilogram. Does the fitted line help you identify more outliers? So I actually took 2 outliers off the first time. The human was the major outlier. The secondary outlier would be this one right here, which I believe at the 400s was the chimpanzee. So we kind of took it out in the beginning, but chimpanzee data may also be an outlier. So this is what's known as bivariate data. It means we have 2 things that we are comparing. So bi represents 2, so bivariate, we are comparing 2 different variables. So having the changing brain weight versus the changing body weight. So bivariate is your keyword for this lesson. If you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.